The data that we have will yield a least squares regression line of y hat equal to 55.402 minus 1.531x, where x is the tug score and y is the Berg score. What we want is S, an estimate of the spread of the y values about the fitted line. We want to use that then to get the standard error for the slope. So our x values are our tug scores, our y values are our Berg scores, and what we're going to need to do this problem is sums from our different x's and y's. So we need the sum of the x's, the sum of the y's, the sum of the x's squared, the sum of the y's squared, and the sum of x's times y's. So if you add up all of the tug scores from the first row, what you'll get for the sum of the x's is 102.8. If you add up the y's, you'll get 729. What the sum of x squared is, where you square each value and then add them up. So this would be 2.2 squared plus 2.3 squared plus 3 squared and so on. And that should give you a total of 767.4. If you do the same thing for the y variable, you will get 33,535. And then the sum of x times y has you multiply the x and y together and then add them all up. So 2.2 times 51 plus 2.3 times 52 plus 3 times 53 and so on. And that will be 4520.1. We're already given the least squares regression line. We could find that knowing what we've learned in chapter 3 on how to find that. It's given to us here though. So our intercept is B0, 55.402, and our slope B1 is the negative 1.531. So to find our S, the standard error, what we do is take S equal to the square root of the sum of the y squared minus our intercept B0 times the sum of the y's minus our slope times the sum of xy all over n minus 2, where n is the number of data pairs. So plugging in all our quantities, what we'll get is 33,535 minus 55.402 times 729 minus a negative, so that will turn positive, 1.531, and our sum of xy was the 4520.1. And then we divide by n minus 2. So if you go through and count, you'll find there's 16 values here. So we'll get 16 minus 2. And so what you should get for this is 2.19. Using this formula to calculate S is highly sensitive to rounding along the way. And so if possible, when you plug in your B0 and B1, if you're finding those yourself, you should try to keep as many digits as you can on those to get this to be more accurate of an estimate. So we get 2.19, and then now what we want to do is use that to find the standard error of the slope. And the standard error of the slope, which is written as S sub B1, is this S we just calculated over the square root of the sum of the x's squared minus 1 over n square root of the quantity of the sum of the x's, then squared at the end. So plugging in what we have, we'll get 2.19 over the square root of 767.4 minus 1 over 16, and then this term is the 102.8, where we add up the x's first and then we square that at the end. And so what you should get here then for your standard error of the slope is about 0.215.